Welcome to my presentation. This presentation is part of the playlist The Quadratic Formula. In this presentation, we will be solving problems related to the quadratic formula. Let us say we want to solve this quadratic equation minus 3s squared plus 3s minus 1 is equal to 0. This is a quadratic equation in S. Okay. If we have a quadratic equation of the form ax squared plus bx plus c which is equal to 0, this is a quadratic equation in x. So if we have a quadratic equation of this form, then the quadratic formula is stating that x is equal to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. So in our case, we are going to solve for s. Okay. Now, as a first step, we want to identify the values of a, b, and c. And once we have identified, then we will substitute the values of those a, b, and c into the quadratic formula. So let us start with step number 1. So the value of a in our case is equal to negative 3. The value of b is equal to 2. And the value of c is equal to negative 1. So as step 2, we're going to substitute the values of this a, b, and c into the quadratic formula. The quadratic formula is minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. Okay. As I mentioned, we are going to solve for s. So let us start substituting the values of a, b, and c into the formula. Minus b minus of the value of 2 is 2. The value of b is equal to 2 plus or minus the square root of b squared. The value of b is 2 raised to the power of 2 minus 4ac. The value of a is negative 3. The value of c is negative 1. The whole thing divided by 2a. 2 times the value of a is negative 3. Okay, we have successfully substituted the values of a, b, and c into the quadratic formula. Now we're going to simplify them. Okay, so negative 2 plus or minus the square root of 2 raised to the power of 2 is 4. 2 squared is 4. And then negative 4 times negative 3 times negative 1. Negative times negative is a positive. Positive times negative is a negative. So 4 times 3 is 12. 12 times 1 is 12. So, and then the whole thing divided by 2 times negative 3 is negative 6. So we have negative 2 plus or minus the square root of 4 minus 12 divided by negative 6. Now, let us simplify it some more. Minus 2 plus or minus the square root of 4 minus 12 is minus 8 under the radical term, the whole thing divided by negative 6. So we want to see if there is a perfect square under the radical term. So we can write that as shown here. Negative 2 plus or minus the square root of negative 1 times 2 times 4. So we will separate them out in the next step, but just for us to know that whenever we have a term which is a perfect square under the radical term, we can pull it outside of the radical term as shown in this next step. So we can write this as negative 2 plus or minus 2 square root of 2 times the square root of negative 1. So square root of 2 is not a perfect square, so we left that term under the radical sign. Square root of negative 1 is an imaginary number. So we know from algebra that the value we can state square root of negative 1 as equal to I. Okay, so therefore, when we simplify this, we can write this as negative 2 plus or minus 2i square root of 2 divided by negative 6, like that. So when we simplify this some more, when we take out the 2 common and then simplify it, we can simplify it as 1 plus or minus I square root of 2 divided by 3. So the two solutions we have are 1 plus I square root of 2 divided by 3, or s is equal to 1 minus I square root of 2 divided by 3. These are the two solutions for the given equation. These two solutions should and must satisfy the given equation. Okay, so in this solution we have a real part and an imaginary part. So this is how sometimes we may have to express our solution. Okay, let us look at another example. Let's say we have a quadratic equation in y this time. 3y squared plus 2y plus 3 over 4 is equal to 0. So this is in the standard form of a quadratic equation. Ax squared plus bx plus c is equal to 0. If this is the form we know, then the quadratic formula can be written as x equals to minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. As a first step, we want to identify the values of a, b, and c, and then plug them into this formula and then simplify it from that process on. As a step number one, let us identify the values of a, b, and c. The value of a is 3, the value of b is 2, and the value of c is 3 over 4. Okay. Now, as step two, we're going to substitute the values of a, b, and c into the quadratic formula. We're going to find the value of y because we have a quadratic equation in y. Okay, so the formula is stating minus b minus 2, the value of b is 2, plus or minus the square root of b squared, the value of b is 2, raised to the power of 2, minus 4ac, 4 times the value of a is 3, and the value of c is 3 over 4, the whole thing divided by 2 times a, the value of a is 3. So we substituted all the values a, b, and c into the formula, and now we're going to simplify it. So this will be minus 2 plus or minus the square root of 2 squared is 4, and then 4 times 3 over 4. We have a 4 in the numerator, 4 in the denominator, those cancel out. So 3 times 3 is 9, and that is what we are left with under the radical term, the whole thing divided by 6. Okay, so 2 times 3 is 6. Now let's simplify it some more. Negative 2 plus or minus the square root of 4 minus 9 is negative 5 under the radical term, the whole thing divided by 6. So we have negative 2 plus or minus the square root of negative 5 we can write as negative 1 times 5. So in the next step, as you can see, I can write this as negative square root of negative 1 times square root of 5, because we know that we can write square root of negative 1 as I, and therefore we can rewrite this solution as negative 2 plus or minus I square root of 5 divided by 6. So therefore we have two solutions for this particular problem. Negative 2 plus I square root of 5 divided by 6, or y is equal to negative 2 minus I square root of 5 divided by 6. One is the real part and another is the imaginary part. So we may have solutions of this kind as well when we solve a quadratic equation. These two solutions should satisfy the given quadratic equation. So in my next video presentation, we will solve more problems using the quadratic formula.